Hello, everyone.
Hello,
We're testing our microphones live on the stream.
I'm talking. Well, I used to be talking.
You were talking at one point. All right. I
Great.
assume I'm on the screen now. Hello, everyone. This week we're going to be talking about post-processing in hubs. The past little bit, I've been working on integrating in a post-processing library, and then kind of thinking about the workflow and all that about how we're gonna get this into hubs. Gonna dive in a bit about like actually how it's implemented because I think it's interesting. And I mostly didn't have to write this stuff. We're using a library to do a lot of the heavy lifting. But I think it's important whenever you're pulling in a library to dig in and understand how it works, so I'll go over some of that as well. Cool. We didn't do intros. I always forget to do intros. I'm Dom. Uh,
I'm
I'm
John.
with John.
I'm also here. I'm playing the part of the useful idiot. I will ask you lots of questions and also hopefully learn about how post-processing is implemented, how you did Bloom, and how you worked around these problems and also what they even were.
Mm-hmm. Yeah, and I think this is a useful format. I like this format of someone who knows a topic, explaining something to someone who doesn't know the topic yet, because it usually the person who doesn't know the topic yet might ask a lot of the same questions that you're thinking while you're watching this. But also we're in a live chat, so feel free to also ask questions as well. And if you're going to ask a question, know that other people watching this later might also have the same question. So please do ask questions. Um, Before we dive into the post-processing stuff, wanted to give a quick update on this other pre-work that happened leading up to this. Building up to doing post-processing, the first thing I wanted to do was get our main game loop in order a little bit more so that it was kind of more clear where rendering was actually happening. Some of this code was in A-frames still, and we have been kind of pulling it out piece by piece. But I was finally able to pull out basically the last piece of it in this PR, and actually we'll look at this in my editor in a second. But mostly it was just moving stuff around. This looks like a big change, but it was mostly just shifting where stuff was. And I landed this yesterday. I put up the PR like 2 weeks ago, and I just didn't get around to merging until yesterday. But if we look at the new main tick in hub, so in hub systems JS, this is where we used to have this big thing called hub systems, and it was an A-frame system. We still keep around the A-frame system because a lot of stuff points to this thing, but this system no longer has a tick method. Instead, just in the same file, we have this function called main tick. And this is now like the entire main game loop, like the entire request animation frame is right here. So you can look here and you know everything that's going to happen every frame, including figuring out the time and delta time that we use. Like we're all generating that now, and it's consistent. Previously, we had a few different ways we were generating time, and so different things had slightly different understandings of what the current time was and that sort of thing. And so we're doing everything here, including like this is like, for example, this is where we run all the A-frame components. You can see like that happens right here, and this is where we run all the A-frame systems. That happens right here. and then we're running kind of the other systems we've created. Um, the ones that have hub systems prefixed on them, like those are the ones that used to be. Those are the ones that we're declaring up here. These are still not bit ECS systems. They're not necessarily thinking about bit ECS stuff. But you also see like the number of A-frame systems that still remain. I put them in this comment, like they're handled in this loop, but I kind of listed them out as I was reviewing this just to figure out like, okay, what is happening and like what order are they taking into. The only reason I haven't unrolled this loop is because custom client developers might have their own systems, and then they have to like make sure to add them here. And I didn't want to do that yet. I think I probably will, or these will just all go away eventually, and then this won't really be much of a problem anymore. Um, and the main reason to unroll it is not really like a performance thing or anything. I assume that kind of gets jitted out in depends, but mostly just so that then we could like put these in different spots. And like we talk a lot about like the execution order of stuff, and you want to be able to look at systems here and say, okay, what this runs before that and this runs after that, and be able to reason about it. And bundling these all together kind of is unfortunate. The order of things hasn't really changed here from previously. Things are still running in the same order. Um, but anyway, the important bit in terms of post processing here is that now, ignoring this composer thing, this render.render, this is like the thing that actually renders to the screen. And having that in ARC code instead of in A-frame code is important to adding post processing, because you can see like, well, if we're doing post processing here, we need to do something else. So yeah, that's that change. That'll be landing on Hub's cloud. Probably not in the next release, probably the release after that. But yeah, that's coming down the pipe, and that was just a minor cleanup. But I think it sets up a good stage for future stuff, including this post processing stuff.
I think a couple of things worth pointing out there is that first, that's like most of the work that the client does, other than 2D render, accepting things, like passing things back and forth from workers. I don't know if it happens in here. Anything that gets queued on the event loop gets processed outside of this tick, right, and in between render frames. And so it may be the case that we aren't making best use of the time between callbacks to request animation frame. We could probably queue up a lot of this work before request animation frame is ready to run again in cases where the system is like fast enough to do all the work that's required.
Yeah, and the browser actually has APIs for this sort of stuff too. There's like concepts of queuing microtasks and all that sorts of stuff, and the browser can intelligently put those in between. There's also like I forget what it's called, but there's a request idle frame or something like that, I think, where you can say like, hey, this is not important work but needs to get done at some point. Schedule this when you can. And so there's lots of stuff like that we can take advantage of. I think it still makes sense to get our stuff all in this kind of nice linear thing where we can look at everything and understand everything that we need to run, and then we can kind of figure out, okay, like what are the bits of work that we can pull out or do in a different way, not all in this one spot.
So then the other thing I was going to point out is that if there are dependencies here, and we've talked about this a little bit before, there are dependencies here, they're hidden. They're like, okay, pick any random system in the list. Which of the systems before it did it depend on? Maybe some of them, maybe none of them, probably at least one of them. But those are not explicit. So if we wanted to do any of this work in parallel in workers or anything like that, it'd be difficult right now without deep knowledge of the whole system to make those changes.
Yeah, and we don't have a great solution for that. What we've done in cases where we know there are dependencies is kind of like bundle them together, like the interaction system. We know that these systems have to run in this order. Like it was actually important that this system ran before this system, and so we bundled them together into one system. And again, like systems are really just functions. Like they're nothing special in BDCS. It's just a function that happens to run every tick. and probably looks at a query and probably does some stuff to entities, but like a system isn't anything special. So we also create these kind of systems that group together stuff when it was actually really important, but that doesn't capture all the dependencies for sure. And I think one of the things we'll probably do is start to talk about things in terms of like buckets of stuff. Like there's a lot of this stuff that kind of needs to happen early in in the tick, like dealing with networking stuff, reading input, setting up, like a lot of setting up stuff. Then it's like all of the gameplay systems run, like all the stuff that, okay, you've processed input, I now have to generate a new state for the world. And then there's like the stuff towards the end, which is like, okay, then now take all that new changes and apply it to things, actually do the rendering, send out any network updates. Like deleting objects is also a good thing to do towards the end of the frame. Like I think there's going to be like a couple buckets we can group stuff into, and if we could be a little bit more explicit about that, I think that'll clear up some of these dependency um, things. But yeah, it's still pretty loose right now. There are some systems that like literally depend on other systems like this, um, but mostly the dependencies are going to be like less obvious, where it's like some system is going to rely on another system making some state changes. So like for example, the interaction systems, take care of adding the held component to something, or take care of adding the interacted component to something, and then systems later are going to be checking like, oh, what am I holding? And so it was important that the interaction system ran before the systems that are checking if you're holding anything. But like again, nothing is making that dependency clear, and that's kind of a thing we need to figure out. So yeah, that's a whole topic in and of itself. But um, cool. So let's move forward with some post processing stuff. So we're using this cool library just called post processing. It's hard to find because it's just called post processing. And if you search for post processing 3JS, you still get some other stuff. 3JS has a built-in post processing set of examples, I guess. Well, I think 3JS has renamed the examples directory to add-ons now, so maybe it's an add-on. But they have their own thing. This is a little bit more featureful than that, and it's still pretty actively developed, and has lots of cool built-in effects, which we're not really using most of yet. But yeah, it's a pretty nice library. And so the kind of I have this the basic idea behind post processing in general, I guess, is good to go over. Like we're going to well, we saw on the frame, we do a whole bunch of work, and then we generate a new image. This is just a 2D image that we've generated, and what post processing is taking that 2D image and then doing more stuff to it, probably processing it after the fact. So all of these effects happen on the 2D image or sets of 2D images. Like sometimes you might need some additional data for an effect. Like you might need to know about the depth information, or maybe you want to know about the normals of some pixel or something like that. Like to do screen space ambient occlusion stuff, you like actually kind of generate, oh, what way is this pixel facing? It's sort of a weird concept, but like you can encode any sort of data you want into images, and then you can take them and generate um, some effects. Um, so the basic way that this library works is you have an effects composer, which you have a single instance of, and then that you add a bunch of passes to, and then that's what you call render on. And so you saw when we were looking at the hub systems here, like when we have a composer, like this is so that you can enable and disable it as a user. Like when you have it enabled, rather than calling render on the normal renderer, we're calling render on this composer. And that gets created in app.ts. This code's still all very messy since I'm still like um, actively working on it. But we create a composer, and then set up a bunch of passes, and then add all those passes to the composer. And like the order matters for these things, right? Because they like they're going to apply a sequence of transformations on images. The other interesting bit is that so the way this is done is we have two. You see, like there's A and B here. Um, we have two buffers we're working with while we're going through the post processing effects, and so we'll render into one of them, and then the next effect will take that one we just rendered as input and render to another one most of the time. Sometimes you might render back onto the same image depending on what you're doing. But a lot of times what you're doing is kind of swapping back and forth between these two buffers. And so like we create these at startup time. So one of the big performance considerations here is that like we need additional video memory to store these buffers. And so like just as soon as you start up hubs, we're now, if you have post processing enabled, you're now going to be using like for like instead of just having the one frame buffer you're normally rendering to for your whatever screen resolution you're rendering at, you're not going to have three of those, right? You're going to have two more that are just used for this post processing stuff, and then plus the original one where you're rendering to the canvas. And then even beyond that, that's probably going to be double buffered and whatnot. But that was already the case. And I'll go over this later, but like these ones are actually even larger than the normal screen ones because these are HDR buffers. These are float 16 buffers because we want to be able to store the entire high dynamic range information while we're doing these post effects until we crunch it down at the end. So like that's one of the big kind of performance or like performance trade-offs we need to think about is like, okay, we're going to be using more video memory to enable this, and so we need to think about what platforms do we want to enable this on. You know,
Why are there four? I see two render targets and a canvas in this
there,
image.
right? So there are three. There are two render targets and the canvas. So like the canvas we already had, and then the two render targets are so that we can. So oftentimes you'll need to like you can't necessarily write to the same frame buffer you're reading from. So you're going to take an effect, like when I apply bloom or something, and this is a simplified version of bloom, or it's a simplified explanation of bloom, and then I'll go over more details. But like, well, let's look at like the film grain thing, right? It's like, okay, I take in the image without film grain, and then I'm going to need to generate a new image with film grain, and so like I need two images to do that. Like I need an input image and the thing I'm writing to. And so yeah, this is introducing two new things in video memory that we didn't have before. And like I said, the other thing is that these are bigger in video memory than the original thing because we're storing rather than just values from 0 to 1 in 8 bits per color channel. We're storing each channel is 16 bits, or sorry, 16 half half precision floating point number. And so they can go over.
I don't have a strong sense of like, let's say we're on a mobile phone and we're rendering this stuff. I don't have a sense of how much GPU memory we expect to have available to us, how much like this all would take up versus the textures we pass over to the GPU. I know compressed textures are a thing. Are they decompressed on the GPU? Do they stay compressed on the GPU? And so they're always taking up relatively little space.
Right.
What percentage of like total GPU memory do you expect to be just these render targets?
So that kind of all depends on screen resolution. That's like the biggest, right? Because these are going to be dependent on what size you're rendering at. This is also why we have like this like maximum render resolution in hubs. Because if you're rendering on like a 4K display, these things can be pretty big. I mean, they're if you do the Wolfram Alpha thing, like so if you have like a 1920 by 1280 times 4 bytes, right? Like this is going to be like a single 1080p frame.
4 bytes because there are 8
channels,
half
right?
byte channels.
No, there are 4. This is like the normal
half
canvas.
float is 32-bit.
Sorry, this is the normal canvas I'm talking about, like just the
Okay.
We have RGBA. That's the
Yeah.
four. That's the 4 bytes there.
Oh,
For
okay.
RGBA. And so this is going to depend on the
That's 8-bit depth per channel then.
right, right.
Okay.
Half float. I don't know how many bits that is actually. Half precision floating point numbers. I'm guessing 16, but I'm actually not positive. I'll have to look. Um, but anyway, like so these are big. But you asked the question of how much can we expect on mobile or something. Like I actually don't have a good sense of that either. Like on a modern like desktop GPU, you're gonna have like many gigs of video memory available. Um, and so like this is not really much of a concern. Um, on mobile, most of the time you're sharing video memory, like video memory and like normal system memory are actually a shared pool of memory.
Mm.
Um, and I I get like in my head I have like 8 gigs or 10 gigs or something is like a modern smartphone has like around that sort of amount of memory. Um, I don't really have a good sense of how much video memory we actually get. I have in my head for like the Quest or something I have like a gig in my head as a number I remember thinking about targeting for like how much video memory we actually have to work with. Um, this is from when we were working on the batching stuff and we were doing like texture atlasing, and I kind of remember like when you start to go over that, you start to get some crashes and stuff. That's another unfortunate bit is like there's not really a good way to like audit um, that I found like how much video memory you have left, or like it just eventually you just kind of crash, which is just really unfortunate. This will happen just from loading environments too. Like mobile Safari is like particularly prone to this. Like if you just use too much video memory, it just kills the tab, and like there's no warning or anything. Um, this is why, like on iOS, I think we do some stuff where we actually resize textures down. If you try to use like a 4K texture or something, we just like we don't know we say no and we don't upload it, and we we resize it to smaller. Um, you also asked about compressed textures. So like those, we have support for them in hubs. We don't have a good workflow for actually generating them. But what's really nice about compressed textures is they are they stay compressed in video memory. So like the GPU actually knows how to sample these things
Okay.
in their compressed state, and the compression is also different than um, like something like JPEG or PNG. Typically, you have to read the whole thing in order to like decode some data out of it. Like there's no way to just like
There's not
I want
random
this
access.
pixel. Yeah, exactly. I
Mm.
want this pixel here. It's really important for um, GPU use, like for the kinds of stuff you do on a GPU, to be able to just like randomly access this part of the texture, just any random part, without having to like read everything before it and decompress it. And so, um, as far as I'm aware, all the GPU compressed texture formats are like tile based, or they'll have like an 8x8 region or something, and then like you can read any one of those regions, and also like they're all like this. Um, Maybe not all of them, but all the ones I've seen are like this fixed size. So it's like I know based on what pixel I want to read exactly what bytes I have to go read. So like every chunk of pixels is going to be the same size. Like this is totally not true for PNG or JPEG. Like the same size image might be completely different sizes. But
That's the
for
requirement for fast random access, isn't it? Like beforehand
there
where you
could
have to read.
be, yeah, I mean there could be. You could have like an index though. Like you could have like somewhere where I look to know where this pixel is, and then go off and read that pixel. Like you don't necessarily have to have completely fixed
Mm.
size in order to do that, but like that's certainly the simplest, because then it's like I don't need any additional information or an additional thing I have to go look at.
Okay.
Um, So compressed texture formats are really good. They're also like it's the fact that we're not using them very heavily in hubs is pretty bad. Like it's pretty like industry standard to like uh, to to use compressed textures for everything. Um, like I said, we have support for them. We're using Basis Universal, which is really this cool compressed texture format that lets you. Um, one of the problems with compressed textures is every GPU supports a different set of them, and especially across desktop and mobile, there's like not a lot of overlap. But Basis is this intermediate compressed texture format that lets you you make a texture in basis, and then at runtime, right before it uploads to the GPU, it can do a transformation from that intermediate representation to whatever platform native thing is supported, and that transformation is like really low overhead. Like it's quite fast to do, because this intermediate representation is sort of like the it sits in like the cross section of how all the like I was saying, all the GPU compressed texture formats tend to work in very similar ways, and so like the data you have there is like kind of readily convertible to the other things, uh, to the other formats that are needed. Um, and so we definitely want to get a workflow where you can start using compressed textures for basically everything. Like not only do they use less video memory, but one of the more expensive things that has to happen is like uploading that texture to video memory. Like takes time, and like there's limited bandwidth you have on the GPU to do that. And so it actually like will improve performance too, to use compressed textures, not just reduce the amount of video memory you're using. Um,
We have a question in chat about draw calls. It's a little off topic, but we're going to only get farther and farther away from this. It's
yeah,
sort
yeah.
of related to the calls we're doing in the request animation frame.
Mhm.
Matt Hargett asks, for WebGL2, draw calls or shaders and workers, does that happen on a separate OS thread? Is there a lock contention in the angle driver that would cause GL2 worker code to ultimately serialize with GL2 code happening on the main thread?
So we're not doing any sort of multi-threaded rendering. You can do multi-threaded rendering with off-screen canvas. Our just the way our stuff is set up is going to make that really hard to do. Like we have all of our entire Three.js scene lives in the main browser thread. In order to like do off-screen canvas rendering, and like actually run all that stuff in a worker, we'd have to move all the Three.js scene stuff into a worker, which would basically also involve like if you watch previous streams, like the way our systems work, they tend to work with Three.js objects pretty directly. um, so it would involve also moving most of our gameplay code off thread. This is not impossible, and especially as we start to remove some of the dependencies, this becomes more possible, because we're like right now it's even harder because A-frame relies on the DOM existing and that sort of stuff, and that doesn't exist in a worker. Um, so yeah, so actually I don't have too much. I don't want to say the wrong thing, so I don't have too much knowledge on what doing multi-threaded rendering in WebGL looks like. But I do know that it's possible. Cool. All right. So we went on a little tangent, but that's good. I like and keep asking these sorts of questions. I think it's totally cool. Like we have we set this for an hour, but I think we'll probably go over on this one, but we'll see. But I think
Also, Matt, if
people in
you
the chat
find
are
out what a satisfying answer to that question is, please share, because I'm curious to know, and I don't know. You asked about the angle driver. I think that's OS specific. Like, is that
angles like the thing
Windows?
that's done to convert like basically it's like a cross-platform OpenGL implementation. And so like on Windows, WebGL actually runs on DirectX, which is pretty it's pretty funny. But so yeah, angles like this big thing. I think it's that's going to be browser dependent. Like it's definitely used on Windows. I think it does get used in other places too, though. Um, just to provide a consistent GL driver.
Okay.
Okay, so we have this effects composer. We have passes. Passes, like I said, are these things where it's like has an input and generates an output image. There's a special kind of pass called an effect pass. And effect pass, and this is one of the main differences in this post-processing library from the Three.js library, is it has this concept of an effects pass, and an effect pass can have multiple effects in it, and it will kind of intelligently combine multiple effects into a single pass. And what I mean by that is it'll take those. So an effect is like kind of there's a limited subset of stuff you can do in an effect, but generally it's like you're going to be like taking some input image and processing and writing to some output image. But if you write it in such a way, it can take those effects and combine them together into a single shader. And so you might have, like we were showing, the bloom and film and copy. These are all like this image is actually from the original 3JS effect composer thing. But in this post-processing library, you don't have a bloom pass. You actually have a bloom effect, and you would have a film grain effect. You do have a copy pass, and that just copies from one image to the other. But these two can actually be combined into a single shader and a single draw call. And
so in this library, are there a bunch of snippets of GLSL code that, similar to like 3JS's shader chunks, they've got like shader chunks that gets combined?
They have all these different effects, and then each effect, is usually going to rely on some number of shaders. But you'll, like, if you look at one of these, like, this doesn't define a main function, it defines a main image function. And that's so that, like, the generated shader is going to take a bunch of these main image functions, and it like prefixes them with a name and whatnot to like make them all unique. And it'll prefix any uniforms that you specify. And then it'll take those things and then it'll call them sequentially. It'll call like the main image from one effect and the main image from another effect and the main image from another effect, and like just keep calling them sequentially. And so you can do it all in one shader instead of having a bunch of separate draw calls to do it, and like shader context switches between each one. So that's like one of the main performance differences in this library. And like, this doesn't really matter for us right now. We're not really using very many effects or anything, so it's not a problem yet. But this is a nice thing to have for people to be able to start piling on effects without like really worrying. Like, you're still running that code on the GPU, and so you still need to think about like, okay, what is the fragment cost of this thing? But you're not introducing like additional overhead by introducing each like, there's not like I said, context switching overhead, and then like just additional draw calls you're introducing by adding each effect. So that's pretty cool. Also, the way this thing does its rendering to the screen uses a single triangle instead of two, which is like more performant on some GPUs, and then also like prevents some of the artifacting you might get along the diagonal of the screen. And that's just a nice additional benefit from using this versus.
If you go back to that image that you had in your editor about the passes, you have a render pass. Is that in our code? Is that like a large series of draw calls?
Yeah, the render pass is actually like the typical render, and we can maybe this is like, yeah, maybe we should just like look at what this actually looks like. So the render pass is like actually, so if you imagined our existing, like without any post-processing, what this would have looked like before is basically this, and then on this side you just have the canvas. And so like we're doing a single render pass effectively into our canvas, and that's it. Like the render pass takes so like the render scene pass, right? There's a render pass that takes the normal scene we have and the normal camera we have. And so when you run that, it's going to go through the scene and like render each object. And that's going to be a bunch of draw calls, like one for every object in the scene that is in front of you and whatnot. Like that's just like the typical thing. I know. Yeah, here's what the bloom effect looks like. It's pretty cool.
Okay, I think the thing that I'm getting is that a pass is not like a draw call. It's like set up the WebGL context a certain way, and then maybe call render a bunch of times with the different uniforms and objects. But for effects passes, that does seem like something that is one draw call. It's like set up the context, but then you're working on an image, so it's just render that image differently, or take render target A and transform it into render target B.
Yeah, I mean, some effects have some additional setup they need to do in order to do their the take render target A and render to render target B. And like the bloom effect is an example of that. And we'll go over the details of how the bloom works. But like there's some stuff it has to do. But then, yeah, the rendering of bloom is just taking an input image and then generating an output image. And that's why effects can be combined together into a single shader. It's because like they're not rendering a bunch of other objects. They are a single draw call themselves. Like they're just rendering that big triangle basically, or you can think about it as a full screen quad. So this scene has a bunch of draw calls. It hasn't been fully optimized, but like so this is like what happens in the render pass. It's like all that stuff, right? Until you get to here. So like that was all the render pass, and then now we're into like the setup for the bloom pass. It's doing this like blur thing. We'll go over it, and then this is like the bloom effect actually happening, which is like apply it to this frame buffer, and you can see here like these are different frame buffers, and then here's where we actually draw to the canvas. And so like this one also, you'll notice the colors on these two here look different. This one is still like the float 16 buffer, and then this one is when like the canvas we're actually rendering to is that 8-bit buffer, and so like that's why the color looks different between these two. It doesn't have like it in order there's no way to display this full range of this image, so it ends up looking darker.
What are frame buffers, 1 through 16 on the left that are partial? Like I kind of see something happening in there.
That's all the bloom stuff. I'll explain that.
Okay.
And yeah.
Okay, I have another question about the difference in color between those two images. You said there's no way to display it the full range because the color data of this first one is in like has 16-bit depth per channel.
Right.
And the one we're rendering to is 8-bit depth per channel.
And my monitor and probably most people's monitors that are looking at this are 8-bit monitors, not like a HDR monitor. So there's no way to display all of the values that.
Yeah. Why do you need the 16-bit depth?
Yeah. So
could you have split it differently in the 8-bit depth and just said like, I'm expecting to go 2 times the usual max value, so 7 bits are
you're losing precision, right? Like
4 times, 16 times. Like you're losing precision.
Whatever it is, you're
like,
losing
why
precision,
does it?
Right? So like because what you want to have, and we do have in this scene, right, is like you have some values that are like really, really, really bright. Like the sun is very bright, and then like this floor is like really not bright. And if you try to compress that down, you wouldn't be able to represent like that large of a range, right? Like and you can, and like ultimately like I was saying, like you have to eventually get down to the screen, and so like you are at some point compressing this down. What's useful about the intermediate steps being in high dynamic range is that like then we can think about, and again this I'll get into this with the bloom stuff, but like you can think about the full range when you're thinking about applying effects and stuff. So like when I'm trying to decide what blooms and what doesn't, I can think in that like high dynamic range space rather than like we've already compressed it down. And like now like the sun being really bright and this image being white, well like the brightest color we can represent is white, and like these are both white. And so, like, I wouldn't be able to say only bloom the sun and not this, because well they're both white. Like I've lost too much precision, and I've lost like
I see. Like that image being white would end up in the way I'd sort of imagined if we were only ever working in 8-bit color space, it'd be like that white is only halfway through the range instead of the full 8 bits through the range, and then
that's how it'd have to be. But then like you really compress down all the rest of this stuff that's lighter, because the sun is so much brighter than the rest of the stuff, and we want it to be right. Like we want it to be very bright, and it's also for like all the lighting calculations, like all of the reason that the sun is really bright and whatnot, like that applies to all of the lighting calculations we're doing. So like when you're seeing stuff bouncing off of surfaces and whatnot, like we want that value to be really high, so that like when it's shining onto a dark surface, it's like it's only reduced, like we do like the whole energy conservation thing or whatever. So like when a surface is being lit, like it's important that it actually is like we're using PBR, like physically based rendering, right? So it's like the values for something really bright actually being very high is important for things to look correct. Um, and colors and stuff is definitely something I still like. I am still trying to get a good handle on understanding HDR and color spaces and all this stuff, and it's deep. And
I once knew a color scientist who went to work at special effects labs, like the one, the Lucasfilms one,
yeah,
the Star Wars special effects lab, and I I heard someone ask him like some question about like, why does this color look like that, and he just like went off at them for
yeah,
half an hour
right.
just about how every part of their question was already the wrong mental model about how light works and how the
That's the
eye
thing.
works
It's
and
like
how monitors work and everything, and it was very entertaining.
there's so much, and like yeah, I've gone into the rabbit hole multiple times of trying to understand this stuff, and there's so much to it, and yeah, you start getting into like really weird stuff where you're like, oh, that's an imaginary color, and like it doesn't actually exist, but like and like just everything about color is weird too, because like there's certain colors like magenta doesn't actually, there's no wavelength for that color, like it's like because color is all this mental anyway, this is a whole a whole thing. um but yeah, so like the reason we want these intermediate buffers to be uh half float is that we want to be able to operate on the full dynamic range when we're thinking about effects. At least certain effects, like we might want to apply certain effects after we've already crunched stuff down. We don't right now, but like we could decide to do that. Cool. So
Okay.
all right, so I think so that very high level overview of how that library works. You have the composer, you have passes, and then effects are sort of this special kind of effect pass plus effects are a special kind of pass you can do. So we've already done a bit of a demo of the bloom. Like this is what bloom is. It's when you have very bright values, they tend to, this happens both with your eyes, but also with cameras where when the thing, the some source of light is so bright that it's kind of blowing out the sensor. It's like it's too bright for the sensor. What tends to happen is you end up seeing like a halo effect or like a blurring happen um, around the bright light source. And the parameters of this bloom, we have a threshold, which is like, okay, at what values are too bright? Like what what luminance value should we consider as being too bright, such that it starts applying this bloom effect. Radius effects, like okay, how big is that bloom effect? And then intensity is just like a how intense is it? It's like a multiplier on top of that effect. And then we can also change some other stuff about how it's actually mixed into the image, and we'll go into that. But like the basic bloom is actually like relatively simple. So like what you do is you have like some input, like the image we've generated, we've rendered the scene, and then we're gonna like any values brighter than this amount, we're gonna like render into another image. Then we're gonna like take that image and blur it somehow, and then we're gonna take that blurred image, take the original image we have, and just combine them together in some way. And so like the combining together can be done in many different ways. That's this function you have here. Like you can, and my drop downs don't render correctly, but you can do add, or you can do like lots of different ways to mix the
Oh, that one looks cool. Oh, that one looks bad.
yeah.
Oh, that one looks scary.
Yeah.
Whoa,
Oh, this one's cool.
that's
Whoa.
very cool.
Whoa, that was on accident, but
Wow.
I don't know what we've done here.
We should
Anyway.
absolutely be playing with this.
But
Um,
like you wouldn't like I wouldn't do this in the bloom pass. If I wanted to do something like this, I'd add another effect that does this to the scene instead.
mhm.
Um, you were about to ask.
After you eat mushrooms.
Yes.
So should bloom have any effect? I see all these parameters are real time, which makes me think they're uniform shader.
Mhm.
Um, Is it bloom or is it something else? If we, let's say we wanted to have the inside, when you're inside, like everything outside looks very bright, and you have higher resolution and you can see the images inside the house better versus when you're outside, there's kind of an adjustment period for your eyes.
Right.
Um,
That's
if we wanted to
actually
do an effect like that, would we use these real-time controls?
we could, and there's actually so that is actually um that's the tone mapping thing. That's going from this high range into some lower range, and it's like where do you focus your bits, right? Um, it's since we can't represent the whole range. Like if I'm standing inside and I'm looking
Hmm.
outside, right? Like we have some very dark values and we have some very bright values, and like since I can like I only have so much precision, um, I can't represent all of that, and so I have to choose where am I like focusing my precision on. And this is true like with a regular camera too, right? Like I'm gonna take a photo or whatever. Like the exposure is like okay, like where am I deciding to like focus my precision? Um, and so this happens at the tone mapping step, and like there are ways to do like dynamic tone mapping, and so like or adaptive tone mapping I think is what they call it. So like when I'm looking up, it's like none of that stuff resolves, and then as I look down, okay, like now this stuff is visible because like it's not as bright anymore. My whole
Mm,
screen is like I'm seeing less bright. So like, but when I look up, it kind of like blows that out because this is so bright up here that it's
yeah.
kind of like most of my screen is this bright area, and so it's blown out. And so like, yeah, with this we can
Is it
actually
happening over time?
it is, and
Like,
you can adjust the adaptation rate, like how quickly
oh,
it.
adaptive rate.
So like I bumped it up, and now it happens very quickly, right? Um, I don't know how well that's coming over on Zoom.
I see. So you actually don't need to do this as an intentional, like, okay, when you're inside, colors should look like
No,
this. You can
no,
just do it based on what part of the
it's what are
world
you
you're
seeing?
rendering.
It's like what are
Yeah,
you
it's what you're
seeing? So
seeing.
like it's how bright is the image you're seeing, and like it uses the same stuff we're using for Bloom. Uh okay, so the way like I was saying, the way Bloom works is we're gonna take some based on the threshold, we're gonna like render out the scene into some other buffer and just the brightest values, or like just where it's brightest. And like so you can see here in the top left corner, the first image there, like that's everything we're going to Bloom is rendered right there.
Yeah.
Um,
And it's not
and
blurred. It's
and
like
it's not
exactly.
blurred yet, right? Exactly.
Mhm.
That's and then the second image is like that's the output of Bloom, like that's like actually what we're going to apply over, like that's after we've done the blurring. Here's what we're actually going to mix into the scene that we've already rendered. And so like if I set this to set, like this is just Bloom,
Mhm.
right? This is the image that we're gonna combine on top of stuff, and it's kind of cool to look at. But um
It is very cool to look at, especially if you change the threshold and
yeah, like
maybe lower the intensity.
if I bring the threshold down, like okay, like now I'm kind of starting to see everything, right? And yeah, if I lower the intensity, like that's and again, like all of these parameters will affect okay, like how much am I blurring it? Like oh, this is like really blurred. Um and so you were asking earlier about this. So now
Hmm.
we can actually understand what's going on here. So this is that first image that gets generated. It's transparent, and so it'd be nice if there was a way uh, in this
Spectre.
inspector JS to like look to make the background black or something so that we can see it better. But like
Yeah.
you can see the yellow area there. Like that's the bright sunspot on the
Hmm.
left here. And so
Oh,
then
does the blurring happen gradually or something?
it does, yeah. So the
Mm.
way the blurring happens, so there's lots of different ways to do blur. The way we are doing blur is based on and by we I mean the way it has been implemented in post processing. I didn't write this, but again, it's important to like look into like how does this stuff work because we're not going to be running this every frame, and so we need to know what's going on. So the way this works is based on this article here, which is I think based on how I think Call of Duty does it or something. But basically, you just keep rendering lower resolution versions of the image. It's called a bitmap blur in this library because it's kind of each time it halves it. So we start off with like the full resolution, and then we generate half, and we keep going down.
Mm-hmm.
And then so now we have all of these like kind of lower resolution versions of the image, and then we start combining them together into each. We start taking each low resolution image and kind of starting to combine them together. And so we take each of these steps is taking the image on the left and combining it into the previous image on the right, and that's how you end up getting this blur. Because you have all of these kind of like you've blurred it by making it low resolution,
Mm-hmm.
and then you're combining it back together, and like the amount you sample from the left image determines like that's what like radius is actually defining, is how much am I reading from this image instead of the image that I've already combined stuff into, right? Because the more you read from the left side, the blurrier, like the bigger a blur you're gonna get, right? Like if I read 100% from the left side,
Mm-hmm.
then I'm or am I saying this backwards? Yeah, like if I read 100% from this side, I'm going to like always yeah, I think I do have it written backwards, because if I always read from the left side, I'm going to end up with this image, which is just like
I
the
can't see what you're pointing at.
oh sorry
Um,
the top image basically, like if I always read from the left side, I'm always
yeah.
going to get the top image at the end, right? If I read 100% from the left side, but as I start mixing in the previous values, I'm going to get this blurrier image, and
On
that's what
sorry, can you
radius
go
is.
back to that demo image? I'm still trying to
Yep.
understand it. So I see like down 6, down 7, up
Mhm.
6. So up 6 is some combination of down 6 and down 7. Why? What is the mix? Like, how much of down 6
That's what
is
I'm
it? How
saying.
much of down
The
7?
radius is what determines the mix. Um,
I see. Like a larger radius, it will prefer down 7 over down 6.
a larger radius is preferring the image on the right. Like it's preferring the, so you're mixing the okay. So I have the lowest resolution image, right? I take that, I render that into a thing. Now I
Mm-hmm.
have that image, and now I have the next resolution up. Um, and I'm going to mix the next resolution up into the image, like the combined image.
Oh, I see. Okay, so like up 5 is actually a combination of down 5 and up 6.
Yes.
And so a larger blur prefers sampling up 6 pixels over
On the
down
right
5.
side, exactly,
Yeah,
because
okay, okay.
and so like that's why I said I think I have it written wrong here. Um, and like if we
No,
look
no, no,
at
that was right. The lower the radius, the more you pull from the left
oh
images.
okay,
Yeah.
I did write it correctly. I just confused myself.
I think I got confused in that image because like down 7 could be basically shown on the left or right of that
Right, right.
image, and it'd be the same.
I want to
But okay,
find
that's pretty cool. I didn't know that.
right, and so like if you actually look at the upsampling material, like this is where the mix is happening here, right? It's like I have the one image, and then based on the radius, I'm going to mix either this the blurred value is you're sampling from a bunch of spots uh, in that image, um, and depending on like I said, depending on radius, you're going to decide which one you're going to keep. Are you keeping the or more of the left one or more of the right one? And the right one is also applying this like this blur by reading from a bunch of spots. Um,
Everywhere around
right.
the target pixel, it looks like.
Mm-hmm. And the UVs there, like if we look at upsample, the vertex shader, like those all come from here. They're just around the target pixel. Right, and so when we were looking at, here's my when we were looking at this, like you can see we're doing, these are the down samples, we're going down, and then we start going back to the up samples. And you can check like the resolution of each of these changes as you, oh, that's not it. Where's the resolution?
Okay, so I understand there's some overhead whenever we have a draw call, but each of these frame buffers are not associated with a draw call, right? This is like one
There is a
draw
draw
call that,
call happening each, right? Like, I mean, each
oh,
of these
there
things,
is.
every time you see a thing on the left here, that is a draw call. You can see here, like draw elements, draw arrays, like, but this draw call is a single triangle. But like
I see.
yeah, when we say
Okay.
draw calls, like we literally mean, like these functions that say draw something, like that's what a draw call is when people talk about draw calls. Usually they're, usually they're going to be rendering a bunch of triangles or something like that. But these are still draw calls. Like they're still, you're still telling the GPU, hey, run a vertex shader and a fragment shader, and not much happens between them. We don't need to like rebind, like between all of these. We don't need to do as much. We are changing some uniforms. There actually does look like more happening here than probably needs to. Like I don't think we need to flip depth testing on and off here. Like that's probably an artifact of this being more general than it needs to be. Um, um, but yeah, each of these is
I
its own.
see. The bind texture and the uniform to F calls probably are
Right,
important.
right. You expect to see those, but like the fact that we turned depth testing back on and then we turned it back off, like that's kind of silly. Like that's just, presumably, I haven't read all the code in this library. Presumably, it's like, okay, after it runs an effect, it's like turns it back on because it's like, okay, well, the next effect might need to, or the next thing that happens might need to have this turned back on, and so that's a little inefficient. In general, in 3JS, like it's pretty good about trying to keep track of the current state of things and only changing stuff when it has to. But I think that there are probably ways to optimize that more. The other thing too is like the driver can also optimize that stuff away to some degree. Although here we are telling it to change, so I feel like it probably has to actually change. But yeah. Anyways, okay. So that's Bloom. I think, yeah, we've gone over. So the values we were modifying are just modifying inputs into those, and so you also notice there was more than one thing happening here. So like this is a separate shader from the thing that ultimately combines them. This is like the effect. So if we look at in post processing, the Bloom effect, the Bloom effect does a bunch of things. Effects can have a update function and then a render function. The update function for the Bloom effect there's a bunch of different ways to, like, you can configure the blur in different ways. So you can do map blur, or you can do like this other method of blurring. And but like the way we have it configured, we are using a luminance pass, and that means like we're doing the thing where, oh yeah, that's an interesting bit too, actually. So like the bit where we decide like, okay, what are we blooming? So that value is not just like so we have RGB values, right? And we're using a single number as our threshold. Like what does that number mean? So that number is the luminance of the pixel. And the way we generate the luminance is, actually this is in 3JS. So it uses this function in 3JS, this linear to relative luminance. And
Okay, so that's taking a color.
and then you're like, well, what the hell
Oh,
are these
doing a
values?
dot product.
Yeah,
Hmm.
and so these colors are based on human perception. We tend to see green as much brighter than uh, red and
Blues.
blue. Yeah, and so like you can see like green, like we're using the green component like way more than blue or
Huh.
blue or red here, and this is like based on again on like how much uh as humans um we perceive colors. Where the hell did that go? So this is like I said, this is based on how as humans we perceive stuff, and it's actually interesting. You'll get into when we start talking about color spaces and all that stuff. This is all uh, it's it is all based on human perception because, like I said, colors are not this like real thing. Actually, like wavelengths of light are a real thing. Colors are a human perceptual experience, and so like there's no like this color is this like I was saying also certain colors don't literally like there's not a wavelength that is that color. It's like how your eyes are combining things that it is receiving creates that color. And there are also like multiple ways to stimulate your eyes to generate the same color but like not with the same wavelength of light, for example.
Hmm.
Um
I'm remembering the like hacker green terminal color stuff, and I'm wondering if like if I have a display that only displays in green light,
mhm.
do I use less power than if I had a display that only had like the blue crystals of LCD screens?
You mean because like we perceive green like for a given brightness we'd perceive it as brighter or something?
Yeah, like
It's possible. I don't
if I just like greenwash in software everything I want to display, am I going to end up saving power somehow because my monitor
like you might be
brightness
able
is?
to lower you might be able to lower your brightness because of that. I don't yeah that's I don't know. um
Hmm.
but anyway, so yeah, so that this value we're generating where we decide like okay what is our threshold is in that luminance uh value. It's like okay how bright do I perceive this color. um
Okay.
um and yeah that's what this shader does. And so where was I? The bloom effect. Um, right. So when it's doing its update, it's like first going to run that luminance thing. So it generates that luminance buffer. Then it's going to take the result of that and then run it through the blurring thing, and then that blurring that the result of that blurring pass. And if we look at uh, uh, like this map blur pass does what we were looking at in its render. It's like okay, it's gonna like loop through and do the down samples, and then loop through and do the up samples. Um,
Okay.
so it's kind of it's all like what you expect, which is
Mhm.
nice. Um, uh, that's Bloom. We talked a bit about HDR. We already talked about this. Mostly, we haven't talked about tone mapping yet, and so we'll talk about that. Or we talked about it a little bit, but like, um, right. So we talked the HDR buffers are so that we can work in
We have
this way.
16-bit depth per channel.
We have it's half float. I should really just. I don't want to keep saying the wrong. Yeah, 16-bit is half float, and you could also use 32-bit like floating. In WebGL1, this is a extension, and then in WebGL2, it became a requirement. I don't know exactly how we want to limit it. If we want to just say, okay, like you just can't enable post processing on WebGL1 uh, browsers. Like WebGL2 is now like quite well supported, so we wouldn't. And since this is just like a post processing effect, it's like we wouldn't prevent hubs from running on those things. But I think for just the half float thing, like the number of WebGL browsers that also support half float is like like even if they're only running WebGL1, I think is quite high. So we could continue to support it, but it might be easier just to say, okay, like we only do post effects on WebGL2, just so that we don't have to like constantly think about, oh, does this work on WebGL1 as well?
Okay, so but the basic problem is we've got an image and each pixel has some number of 16-bit channels,
Mhm.
and we want to reduce it into an image that has only 8-bit channels, and tone mapping is the function by which we do that. We say like where do we want to insert precision for each
Exactly.
channel, and
And so there are various tone mapping functions. Like one of the kind of popular ones is this ACES filmic thing. Uh, uh, well, anyway, it's
is it the same for every color channel typically?
uh, they can be different. I don't know about ACES in particular. Um, but so there are various uh, there are various tone mapping functions you can use in Three.js, and we are just using one of these. Um, this is the ACES Filmic one. It's like they're kind of complex. Like the there are a bunch of different ways to do it.
I'm
That
seeing 3x3 matrices and
mhm.
stuff. So
Yeah, yeah,
okay,
yeah. Yeah, exactly. So like
with
that.
like
Well, it's because you
yeah.
have that curve and you need to express that in some way, and so like it's being done with matrices here to like I guess approximate that curve.
Well, that also means that each color channel is being transformed
Can be.
differently.
It can be. Yeah.
Well, look at the numbers; they're not the same in every
Right. Okay. Yeah. Yes.
column.
Yes. Um. So, uh, this also gets into so we were talking about if you were at the meetup last time, we were talking about like, oh, can we just like invert these or something for the problem I'll describe later? And it's like it's not obvious how you would do that for all of these. I think it can be done, but it's like you have to do it for each one. Basically, you have to figure out like, and by invert I mean it's not quite invert. I want to take. Well, why don't I get to that when I talk about the actual problem that's trying to
Okay.
solve? Um, but anyway, so there's these different tone mapping functions, and we can use one, and they uh, um, we do that also in a pass. So we have this tone mapping pass. We tell it like what kind of tone mapping do we want to apply, and then it is taking that input image and then generating that output image. The other interesting thing to note, so with this effects composer thing, right? So like by default, every effect is just going to be um, taking. It has those two buffers that it's swapping between, um, and it's going to just take it and render to the other buffer. Um, Eventually, something has to render to the screen if you want to see anything, and it can. You can tell it to do that automatically for you. It'll kind of just try to like if it's whatever the last pass is, we'll just render to the screen. Um, but you can also turn off automatic and then manually control it. And we do that because we want to be able to have a little bit more control over what. I'll get into that with the UI stuff, but like sometimes we want to render multiple things to the screen, and then even for example these debug images, like I'm rendering the whole scene, and then I'm also just rendering those debug images just directly onto the screen as well, um, not into some intermediate buffer and then rendering them.
Hmm.
So I want to be able to specify which ones render to the screen, and the tone mapping pass is like the first one that does if we're not doing this UI business, because like the tone mapping pass is taking this HDR buffer and then like now we're ready to compress it down, so we can just render it directly to the screen to the 8-bit like canvas frame buffer. Um, I haven't looked at chat for a while. Is there anything? Sorry, this is riveting content. Me reading chat. I think I don't see anything that pops out at me. Let me know if there is anything. Right. So you have to specify what rendered to the screen. So tone mapping is what actually ends up rendered to the screen. We have these different tone mapping functions available. You'll be able to configure this as you can right now. So like in the environment settings component in Blender, you can already configure this right now, and this will still be true, but it's being done in a different way. So like the way we were doing tone mapping before, if we're not using post processing, the way tone mapping happens in 3JS is every shader does its own tone mapping as it's rendering the object. So like we have our canvas frame buffer is just 8 bits. I'm rendering I'm rendering some object. I'm rendering the floor or something. And as I'm rendering it, all my lighting calculations are happening in 16-bit space or even 32-bit space, depending on like the precision you have set in the shader. So like I can generate all that stuff, but then like I have to decide like, okay, what color is this pixel? And so the way that happens, if you're not using post processing and not using high bit depth frame buffer, is just right at the point where we're going to write out the pixel in that shader, in the shader that's rendering the object, the floor, whatever. I apply tone mapping there, and so like every shader in 3JS has these tone mapping functions in them, and it just does it in line. Because we want to operate, like I said, in this high dynamic range, we can't do that. We actually have to turn off tone mapping at the 3JS, like every individual shader level. So like each shader no longer does its own tone mapping, and then we do tone mapping as a post processing effect, like on the whole image. So the way we do that is by turning it off in 3JS. One tricky thing that introduces is we have for like images and UI, we were previously turning off what have I done with all my values here? Oh, I'm still rendering the let me just refresh. I'm still rendering just the bloom image. So images and UI, we wanted to keep the original color of the image. So like when I have some image, I want this image to show up on my screen as if I was just loading it in a web page or something. Like these color values, I want them to look exactly the same. They're actually not right now, and there's how can I show this? Here, if I do this, this is almost definitely is not going to translate over to Zoom in a way that is meaningful because it's pretty subtle. But we could previously turn off tone mapping on the shader level for any object we were rendering. Just at a per object level, we can just say, oh, don't tone map this object. And then when 3JS goes to render that thing, it just doesn't run that tone mapping function. And so then like the input pixels you got from this image are the same as the output pixels you get on the screen. Because we're now doing tone mapping as a post-processing effect, well, we can't do that anymore because now we don't know what object every pixel is. And then also like, when you're combining things, like when you have transparency, well, this pixel is multiple objects, right? They're being mixed. And so there's not an easy way for me to say like, well, tone map the reflection part of this pixel, but not the part that was behind it. Previously that just worked because we were doing it as we're rendering each object. So like, and we always render transparent objects last. So like I'd render the image, I don't tone map the image because the image says don't tone map. Then when I render the window part on top, I'm going to tone map that value before I write it into the buffer, and then it's going to get mixed with the value of the image there. And so like this isn't a problem. But because we're doing this post-processing stuff and we want to keep this high dynamic range while we're doing the post-processing stuff, we can't now control tone mapping for object in the same way, we're applying tone mapping to the entire image. The other problem too is like, well, this image now is also part of what is having bloom applied to it, right? So like I can bloom the image too. And like maybe that's a feature. Like that can be cool, but it can also be bad because like, well, the UI also is the UI is also being rendered, and well, I can bloom the UI too, and that's kind of a usability issue potentially. Um, you could make the argument that like, okay, I'm the artist of the scene. I'm going for a certain effect. I'm creating a dreamlike scene or something, and so like by having the UI and images do this, I'm like creating an experience, and this is cool, and maybe that's correct.
I found it hard to engage in this problem because of the design questions around what you actually want. Like
Right.
UI and images to me are different in that I find it more acceptable that the image would bloom because you're pulling something into this 3D world.
Yes.
The UI being in the 3D world to me is an accident. The fact that the UI gets, for example, if it gets obfuscated by something else, like if it's partially behind another thing, you don't see the buttons. I feel like that's an accident.
I can't tell. Like that this is really tricky because I don't know. Like, yeah, is it wrong that the buttons are behind that thing? Kind of. I mean, like it helps me know where that thing is in space, but obviously, like, well, it being covered up is not good, I guess. But yeah, part of the difficulty is there is no there's no correct here. It's just kind of like, well, what do you want?
Mm-hmm.
Um, and yeah, I don't know what we want. The images thing, it's like the
Or rather, so for the UI, the other difference is that as the app developer, the people supplying the UI,
mhm.
we can decide to change the UI's sort of in-game colors depending on whatever we want, depending on the scene's post-processing effects. Like we say that the color of
Well, but
the
it's themable too, right? And like when you're defining your theme,
Mhm.
and I say, well, my company's brand color is this specific shade of blue,
Yeah.
and I want the buttons to be this color. Well, it's gonna only be that color if they're using no tone mapping.
Yeah.
Um, and that seems bad, especially because like, well, every scene might have a different one, and so I can't just say, um, oh well, I'll just change my color to adjust. Like this is what I meant by the can we do some sort of inverse tone mapping thing? Um, like where what I want is I want to be able to say, okay, like this is my color blue that I want for this button,
Hmm.
and I want to when I'm rendering the button render a different blue such that when it gets tone mapped will be back at the value of blue that I wanted. Uh,
Hmm.
um, and that seems like it should be possible to do with some like precision error being introduced by doing it, but like it seems like you should be able to get pretty close. I don't know how to do it generically, and so I think we'd have to do it for each tone mapping function. It seems possible to do. I haven't tried to work out how to do it, but it seems like it should be doable. And that solves the tone mapping problem. That doesn't solve this other problem of like, oh, it might get bloom applied. Again, I think like you were saying, like for images, it feels a lot more reasonable that, well, yeah, if you have an image in the world and there's a really bright value in it. The other thing is I think we can do this through tooling. We like bloom threshold should probably be above 1. Like it should only be for things that are actually kind of exceptionally bright. Again, it's an artistic choice, and like maybe you want this to look unnatural, and maybe that's something you're going for with your scene. Um, but in kind of like the physically based whatever, like it's the really bright values that are going to bloom, and that just naturally is going to be the stuff that is above 1 if you're using like HDR light maps and HDR environment maps. Like that is naturally just going to happen, and so I think if we start our thresholds at 1 in Blender and like we make it kind of obvious when you're going below it that you're doing something, um, I think we can avoid a lot of that problem with images. Again, that doesn't answer the tone mapping thing, but it does answer the like okay, well, what if I make my threshold low here, and now this image is glowing? Like
Mhm.
maybe I want that. I don't know. Like the, that's not obviously wrong to me. It's like, well, I made this white thing, and I told you to bloom anything that's below that value, and so, well, that's in my scene, and it's below that value, so it should probably bloom. Um,
Okay, well, I can sympathize with wanting UI colors to be at exactly a color in the output image.
mhm.
I don't know, like I think there's a good argument about what are reasonable defaults and stuff like that, and what happens when that brand logo is behind a window in the 3D space and someone takes a screenshot of it and posts, and then the owner of that brand is upset by how it looked. But it's like
I mean, the
it
behind the window though is like, okay, that is different to me. Like, okay, the fact that like, well, now those pixels are white or yellow or something. It's like,
yeah.
well, yeah, like there's a window in front of them. That's different than like here, like this purple is not the right purple or something. It's like I'm
I
looking
don't know
directly.
why that's different. To me, that's like I'm imagining you sponsor a conference, and so you want your logo to be somewhere in the space. You're paying for that logo to be somewhere in the
Hmm.
space. You might actually have an agreement with the venue or like the conference host to say you have to light our
Right,
banner a certain way
right,
so that it looks,
right.
you know, just so. Um, but if you didn't agree to that and they put it and there was like a shadow on it, I don't know. Is anyone upset? It just feels
Yeah, I
like
don't
a
know.
weird sort of like, well, but
Okay,
it's
here's a and I'm gonna do this, and it's horribly broken right now. But like the camera, uh,
yeah.
so ignore the fact that it's horribly broken. Um, this is because we no longer have a depth buffer on the main canvas anymore, and so
Mm,
now
looks good
that's
though.
rendering without a depth buffer. But like this viewfinder
Yeah.
is now in the world, and it's kind of being double tone mapped, right? Because like
Mm,
I generated the thing, and like now the photo that I generate out of this thing, inherently, okay, well I generated this thing, it had tone mapping and whatnot, and then now, well, this image is now being tone mapped again because well the image looked a certain way when I generated it, and
mhm.
I wanted it to be that way. So like when I open the image, like uh I I I I want this image to be the tone mapped nice image, right? Like but then when I have it in the world, I don't I want to see what the image looks like, not what it looks. I mean, I don't know, maybe it's correct. Like it
Yeah,
should
it's
look.
hard to say. I don't know.
Yeah, I don't.
How much does it matter that these things exist in the world, in the scene,
Yeah,
in the game world? I feel like if what your scenario for using hubs was a purely like, okay, I'm using the computer to talk to people and see media and whatever
right.
else, then the environment itself and like none of these issues would come up because you'd be in wide open space
But that's
and
not true though. Like you should be able to have a meeting about images in the pool. Like why not? Um, so I think it really depends on use cases, and depends on. I don't know. There's no perfect solution. So like what you were seeing there is
Mhm.
like the do nothing solution. It's like, okay, well, we have this problem. Like images are now being tone mapped, and if you set the bloom parameters in such a way, like they'll be not. Um, the There are various different ways I tried uh solving this. Um, so like the one I think I'm going to land on, or at least like have it be optional to opt into for things, is like, okay, well, we just render images after images and UI
Post processing.
after doing all the post processing and rendering, and then we can do whatever we want there. So I have this flag I can flip on. Um, and I'll explain how this works in a second, but just to um, okay, so now images. even if I bring my threshold down and bring the value up, the image like doesn't bloom, and it's
Okay.
also actually displaying the right colors now.
Okay.
And so like that's mostly good. And same thing for UI. The UI always renders in its correct colors and without having any post effects applied to it.
Yeah.
Where this slightly falls apart is here, right? So like this image is now behind the window,
Yeah.
and you see like it still gets occluded correctly by this
Yeah.
the wall here, because well there's a depth buffer and we know like these pixels, the pixels of that image are behind these pixels, and so like we don't render them.
Hmm.
But for transparent objects don't write into the depth buffer, and so as far as when I'm rendering this image, as far as this image is concerned, well, there's nothing
It's as
there.
if there's no window
Right.
anywhere that there's that stuff behind it.
Say that again. There's no window.
It's as if the window's not over
Right, the window
top
doesn't
of the.
exist. Right.
Yeah.
The window doesn't exist because it's rendering after. Like the reason
Hmm.
the window renders on top of this easel is because we literally render it afterwards, and we
Yeah.
say don't check what's there.
Yeah.
We turn off depth testing when we're rendering the transparent objects. But what we're doing here is, and so like this is now like partially through the window, for example.
Yeah.
But now we're rendering images and UI all after. And for UI, it's like kind of better in many ways. Like you were saying, like it's kind of nice that the UI is now not obstructed at all. Like, I mean, it's still being obstructed by the depth buffer. We could also not do that. We can literally always render it on top. For images, I think we want them to be occluded. UI, I definitely can see the argument.
Actually, I've played with that when we were redoing like where UI placement was. I did the thing where we draw it on top, and I ended up not liking it because
Well, it's bad for
well,
like
just knowing where things are in the 3D space became.
Yeah, well, look at all the waypoints out there, right? Like I don't want to see those from everywhere.
Yeah.
Right?
Yeah.
It's important that like those get blocked. So
I don't know if those are the same as UI.
okay, we could decide what is separately UI. They are UI right now in that. Look, there's a UI layer, and they are on the UI layer right now. All sprites are. But yeah, we could treat those separately if we wanted to, for example. And so like this seems pretty good. Like this trade-off doesn't seem too bad to me, where it's like, okay, well, it's another thing you have to think about with transparent objects. But also like I can opt into this for my image.
I think I like this for UI and not for images.
I think for UI, it's like definitely a good idea. For images, I feel like you should be able to just opt into it, right? Like if I like really care about, well, and for like the camera viewfinder might be an example where we do care about it. And we just say, well, unfortunately, the camera viewfinder now, like, well, I guess it's not on the UI layer right now, but like if it was, like, okay, we say, well, now if you put the camera behind glass, it's gonna look a little bit weird. But I don't know, like that's not too weird. But what about an arbitrary image I bring off the web? It's like, again, if I'm talking about the image, I cared that the image looked like the image more than I cared about it looking like it's behind this glass. And I guess I can only decide that as the user, like what's my use case. Well, like, do we want that to be the default? Like when I just copy paste the URL into the scene, like if
is this something that we can decide on a per image basis each frame? Like,
yeah.
If we did
we can do it only when you're inspecting it, do we not?
Only when you're inspecting it, or can we do? I'm wondering if we know whether the window is rendered in front of this image, but I guess not, because the window isn't its own object. The window is part of this large environment thing. You can't just do a Z or like a distance check to the window. The window isn't a thing.
The window is a thing. Like there's a mesh, but like in terms of like once I've rendered the scene, and I'm just looking at the 2D image, the window isn't in the depth buffer, so like yeah, it's not a thing in that regard, if that's what you mean.
But yeah, no, but also in 3JS, like that window is probably part of a mesh that's like the whole house.
No, I think it has a separate material, so it is going to be a separate mesh. It doesn't have to be. Like you could have an alpha channel on the material, but I think like that is a separate draw call right now, probably.
There's no guarantee that each
No.
window is its own object. Is all I mean.
So yeah, so that's like that.
Okay, that's a reasonable way to do it for when you don't want to apply post processing, and the trade-off is you don't get reflections from windows and stuff like
Right.
that.
Then like the other thing I tried is like, okay, well we can actually and this, there is a built-in feature in this library for the bloom effect, but like we have to think about this for every effect in theory. Like when we're doing that first step where we generate that image where we decide, okay, like what's going to bloom, we can do whatever we want there. And so one thing you can do is like, okay, figure out what pixels are image pixels. I don't have a demo of this because it was like I don't think I like that technique, and I or like I don't. But besides that image, I don't have a demo of it. There's a video in Discord of it too. You can see, but basically figure out like what pixels are image pixels or UI pixels or whatever, and then when we're generating that luminance pass, like when we're doing that thing where we figure out like when we're generating that for the top image there, figure like to mask out image pixels from that.
So images aren't going to bloom.
Right. And the way you do that, like, because well, how do you mask them out? Well, we render just the depth information. Like we render just images and UI to a separate buffer, just the depth of them. Like, okay, how like at what Z value is this image at? Then when I'm doing that luminance pass, I can say like, oh, if the pixel I'm generating right now is at or behind the value I have stored in my mask, don't include that in bloom, right? Like you're using the depth buffer to decide like what pixels are these objects on, like because you can't just say oh, render all these objects and then any objects that this pixel touched, like anything that okay, just render just this image. Any pixels that this image is rendered on should be masked. You can't do
Right,
that
because then you can't include things.
Yeah, I mean that could be behind the wall, right? And so like it certainly should, like these pixels up here are not the image. And so
okay,
the reason you use depth to do masking is so that you can still get that. So the problems with
so then if I'm, how do you, but okay, you're writing that into the depth buffer
into
and then
a depth buffer, not
into
like,
a depth buffer, and then you render the windows and they're closer.
No, I'm just rendering just the objects I want to mask out. I do a separate depth pass
I
with
see.
just
Okay.
those objects. I'm like, okay, I'm going to generate a mask, and I'll write just the objects that I want to mask out into a separate depth buffer. And then when I'm doing the luminance pass, I will take those, like take that depth buffer into consideration. I'm like, okay,
yeah, okay.
When I'm doing this,
if that's the closest rendered pixel, basically, then the luminance is 0. It's not luminant.
Exactly. And so then you get it masked out. That has the kind of, again, with transparent objects, you end up with a similar problem where when you put a thing that is masked out behind a transparent object that should otherwise be blooming, like in this window you see here, like that the bloom on the window should still be blooming because the image is behind the window. So like I'm not blooming the image, but I do want to bloom the transparent window. But the problem is, as far as the depth buffer again is concerned, like, well, there's nothing there, and so the image is the closest thing, and so well that should be masked out and not bloomed.
Why does the, say that again? Why did you mentioned earlier transparent images don't write to the depth buffer?
Oh yeah. Well, that's just how we render transparent images. And
there are multiple depth buffers involved now, so
right, but the window's only being drawn to the one. It's not being drawn to the masking depth buffer. We could render, but like we wouldn't know what to render. Like we can't render in the mask. We're just rendering the images, right?
Mm-hmm.
Then when we're going to render the scene, or doing the luminance pass on the scene, the transparent thing doesn't render into the depth buffer there, and so like it you're comparing against the values behind the window, and so the image ends up masking out and I know you can't see where my mouse is. Like the image ends up masking out the bloom that should be happening on the window.
Oh, right there in that image where the sun spot
Right.
is on the image, that's supposed to be bloomier. That's supposed to be
Right.
fuzzier,
It should
blurred.
look like the
Oh, more
bright,
like
yeah,
that.
like that. But it's not because the image is behind it. There's a video of this in Discord. I can't do the interactive
That
demo of it 'cause I
that
don't
makes
have it,
sense.
but but yeah, and so that's a trade-off too. That feels like a slightly less like bad effect in many ways, but there's also like a performance trade-off and like a complexity trade-off here too. Because
Mm-hmm.
like, okay, I'm having to generate this separate depth buffer. I'm having to compare them now. You This also has to, now every effect that you want to apply has to think about this mask too. Like the post-processing library has this selective bloom effect, but it does not have a selective any other effect. And like you might be able to write a kind of generic selective effect pass or something, but like it'd be something we have to do. And like the the selective bloom effect implements this thing I said, like where it's like using a depth material to decide how to mask it out. We'd have to think about that for every effect we want to apply, and that's added complexity. And uh, it also, the other problem, I think I mentioned this in here. Right. So the way the depth pass works. So 3JS has the concept of like override materials. I can say render this scene, but instead of whatever materials the objects had, use this one instead. And because remember, materials are like what determines what shader is getting used when you're rendering an object. So if I want to just like render just the depth of an object or something, well, I need a custom shader to do that. And the way you do that in 3JS is to say, put an override material on the scene and then render the scene. Override materials, though, like that's also overriding the vertex shader of the thing you're rendering. And so anything that has a more complicated vertex shader won't necessarily render correctly into that depth pass. So like if it's a skinned material, or like the text, text components have a custom vertex shader, our sprites have a custom vertex shader, even our cursor has a custom vertex shader. Like all of those things need to kind of be accounted for in this depth pass material that you create. Like
I
whatever
see.
this material thing
Yeah.
like needs to know all those different varieties of things where the vertices can end up, because like it's rendering those things. And like there's no way to just override the fragment shader. And like that wouldn't make sense. You can't just override the fragment shader because like, well, they rely on each other, right? Like the vertex shader is going to write some certain values out and the fragment shader is going to depend on them. And like, well, certain vertex shaders might be compatible with certain other fragment shaders, but not generically. So anyway, like
Very complicated.
this is all technically possible to do. It's all solvable. Like there's no like hard limits
Mm-hmm.
but it's certainly a more complicated solution, and I don't really think it's like significantly better. So that's why I'm leaning towards this first one. Like this first one, especially for UI, I think really is a pretty good balance of things. And like this transparency issue is an issue, but like I think if we make it like a thing you can configure, so I can make I think what I'll end up doing is just having a layer component where you can just say like, oh, is this on the NoFX layer? And if it is, well, no effects are going to be applied to it, but you got to think about transparency more. Like
Mm-hmm.
it's just another thing you have to think about with transparency. And I think that seems like a suitable solution. And we didn't look at it, but just to look at how this works. This scene has a lot of draw calls, by the way, as you can see. But so we rendered the whole scene. We did our bloom thing, and like notice the image is in here, right?
Mm-hmm.
And so then we do we did our thing. We did our tone mapping now, and now we start rendering the UI. So like I don't know what this is rendering, probably like the cursor or something, and then we render the image, and then there's some other bits of UI probably behind stuff. There's like I don't know, I don't know what all these things are rendering, but like various bits of UI, and so now we have the rendered. So this is still in the float 16 buffer, but like already like the background has already been tone mapped, or like all the background stuff has been tone mapped. The image hasn't been tone mapped or anything. It's just, but all the values in this image are now below 1. Because the values back here were below 1, and then the values in the image were also below 1. If you put an HDR image, actually, it's going to get clipped because we're not applying tone mapping to it.
What is that last? Why does the canvas frame buffer look different?
This is the same thing I was talking about before. So like this image that I've selected is the float 16 buffer.
Yeah.
And then we're taking that and drawing it into the 8-bit buffer. Now, these are storing the same value. Like from here to here, like I still have values from 0 to 1. And
okay. Spectre is just displaying that differently.
Right.
Even though the values are the same.
Right.
It's probably doing some tone mapping,
exactly.
basically.
Yes.
Okay.
But like the values from here to here should be the same. With the exception of, like I said, if you were rendering an HDR image, like if you had brought in I don't even know if we have a way to do this. I think there might be a way to bring in an HDR image. I'm not sure. There might be no way to do it, but imagine that you could. If you brought in an HDR image here, well, you told us not to tone map this. You told us not to apply any effects, and so like when we go from here to here, the image would actually get clipped.
Yeah, it wouldn't look right, and
it wouldn't look right, and it would like literally like it wouldn't be tone mapped either. It wouldn't be crunched down. Like you would just any values over 1 are just going to become 1. Yeah, are going to become 1. So this feels like a pretty good solution to me. It adds there's some slight additional overhead because
actually, would it even be 1? Like, does it do clip clamping, or would it just be whatever the lower bits values would be? Like it could be anything.
I don't actually know, but I assume it would clamp, but I'm not positive.
Okay.
So the only added overhead here is when we have the image, the not rendering the images thing turned off, when we're doing the do nothing approach, we would go from the bloom. Actually, I have it up here. So we would go from this, this here. This is like the untone mapped image with bloom applied.
Yeah.
Into the tone mapped image with bloom applied, and like the tone mapping thing just writes directly into the canvas buffer. So that's without doing anything. The added overhead of doing the UI thing is, well, we've done the thing where we generated the untone mapped image, then we need to tone map it, but we need to like keep that in this buffer, not because we care about the color precision, but like the canvas actually does not have a depth buffer now. Like we just don't. We could give it one, but it's like wasteful because we don't use it ever. The only thing we're ever writing into the canvas now is just images. So we don't generate a depth buffer for our main canvas anymore. So while previously here we were able to go from untone mapped to tone mapped directly, like the tone mapping thing writes directly into onto the screen. So here, so like if you have you're not doing the render UI after thing, the tone mapping pass can just write directly into the canvas. Does that make sense? But for the UI thing, we can't do that because we still need the depth information while we're rendering the UI, and so we need a buffer that has a depth. Like we need a frame buffer that has a depth attachment, and so we do the tone mapping into one of those intermediate buffers still. Then we render all the UI, and then we have to do a final like additional copy step from the kind of intermediate buffers we generated into the actual canvas frame buffer. And so this is an additional copy that has to happen that doesn't have to happen in the other case.
Can you show the screenshots you had in your editor again? Still thinking about the bloom on the window in the latter case. So if we're willing to have like arbitrarily complex shaders and fragment shaders are, we make compatible with depth right.
The vertex shader.
Vertex, sorry. We make our vertex shader, compatible with our depth right fragment shaders. Imagine like some calculations we want to ignore the transparent objects, and others, like in this case, we kind of want to know about the transparent objects. If we ended up wanting both, would we have like a multi-channel depth texture buffer, I guess, where the image and UI write to the don't tone map me depth buffer, and the window writes to the all objects, including transparent objects, depth buffer. I don't have a well-formed question.
How do you like the tough part too is like, how do you know? You do need to differentiate between transparent and non-transparent objects too, because like if the transparent object writes into the depth buffer, even in some like say it doesn't write into the main depth buffer, just some special depth buffer. It's like, well, when I'm rendering that image, I need to know that it should ignore that depth buffer bit. It's like, well, no, it's transparently depth. It's not like regular depth.
Okay, that confirms my understanding. Like, in that, okay, if you're willing to have like really complicated shaders with, you can have all the information you need at every step of the render pipeline to say, okay, this is not a tone mapped image. We're going to like render it behind this window, but the window is still going to have bloom values applied, like from reflection of the sun. You end up, the trade-offs come from not wanting to have all the information present at every stage and then have to account for it in every shader.
Yeah, I think that's right. I mean, you probably can make all the but you might need to do even more stuff where like you're adding some additional metadata to the like meshes to do that. I don't know exactly. I mean, shaders can be arbitrarily complex and you can do whatever you want in them, more or less. So like the answer like to can you do it is like probably yes. But like, can you do it reasonably and like generically? Yeah.
Okay, I feel like that was a bad question on my part. Sorry.
I haven't gone too far down this rabbit hole. Like I've gone far down enough to decide that like, okay, this probably doesn't seem worth the trade-offs. Like there's also if you look in the Discord thing, I also posted some other stuff. Like there's also some depth artifacts that you get like in that comparison where you're like, oh, is this that kind of pixel? Like you're comparing values and there could be like, in the same way you get Z fighting where like I have two objects that are really close to each other in depth, well, I can kind of get Z fighting in that comparison too, where I'm like, this shouldn't really happen for the most part because you're literally generating you're rendering the same meshes, and so you should end up with exactly the same depth values, but like you could introduce errors somehow. I was just speculating on this, like I didn't actually see it. Well, like I was able to get it to happen by like introducing a in this selective bloom material thing they have like a range you can use to compare, and so like I made that range larger, and then like I can get like I was able to get like ghosting artifacts where I had like the image partially through a wall, but like it was still occluding bloom. You just have to look at the image; it's too hard to describe.
Okay.
So yeah, so I think there, like I said, there are a few different ways we can do this. Where I'm leaning is to do do the separate UI pass. Have UI definitely generate like not be tone mapped and not have
Mm-hmm.
bloom applied to it.
Mm-hmm.
And then images, I think, will be somewhere in between, where you can decide what to do with them. The question in my mind is like, what are we going to do by default? Like, if I paste in an image, um, will we put it on this layer, or will we try to just say, okay, well, it's going to be tone mapped and bloomed? I'm not sure where to land on that. We talked about this a bit at the meetup last Friday. We'll probably talk about it again tomorrow. So if you have thoughts and opinions and want to talk about this stuff, come by the meetup tomorrow. But there's no
Okay.
obviously correct solution. It's like basically different sets of trade-offs, and we have to decide which ones we want. But yeah, for UI, this seems like the obviously like it doesn't even seem like a trade-off. It seems like I actually wanted this to not be covered by that window reflection. I think like I do want it to be behind the wall so that I'm getting a sense of depth, but like I take it back. I don't know what's it's not
Yeah.
obvious. Uh, um,
It's easier for me to imagine wanting the UI not tone
yeah,
mapped than it is images. Like
right.
images, I feel like in a yeah.
But like you
But
can, but I was able to provide cases that like I think you would agree with, like the camera thing. It's like when I take a picture from the camera, it's instantly now going to look darker than it actually was, or at least different than it actually was. I guess I should say. Like just taking this photo is going to cause.
wow, take that photo. That looks awesome.
Well, yeah. I still need to fix that. So like basically what needs to happen is the camera also needs to end up going through some amount of this effects composer.
Mm-hmm.
Probably all of it, I guess. The unfortunate part is that the passes include the camera that um that the pass is using. So like the render pass is a pass from the main scene camera. And so like the camera tool is going to need its either its own effects composer, or we're going to need to like mutate these passes as we want to render the camera tool. So like the camera tool is going to need to take this camera and or like the camera that is stored on this render pass and use its own camera instead.
Mm-hmm.
So that needs to happen. Oh, the other, this is just maybe slightly interesting, but the way I'm doing these debug images is just another pass. So I have I just create another scene, and I put some I make another camera that's just an orthographic camera, um, like a no perspective, and then I just generated some. I'm actually just using that create image mesh function we have. Just made some quads with those image textures, and the textures I'm putting on them are like the textures from the different effects, like the intermediate textures. Like this is the luminance texture from the bloom, and then the actual output texture from the bloom, like the luminance texture from the bloom and the output texture from the bloom. And then I have a render pass that renders the debug scene and using the debug camera. And you see it's ignoring background so that it doesn't render the scene background again, like the environment map, because 3J, or actually I guess that scene doesn't have a background, so that's not strictly necessary. Um, this is important though. Like I tell it not to clear, so by default a render pass clears whatever buffer it's about to write into, and that would get rid of all the contents of the screen. We definitely don't want that. But I do tell it to render to the screen, and so like if I
Wait, why would can you show the code again? I thought this was a different debug pass, render pass.
yeah, this is another pass that we run after all the other passes. This is generating these two images on the screen here.
Okay.
And so I can show you what that looks like in Spectre. So, but yeah, we don't want it to clear the screen, because like, so the one of these, the either the copy to screen pass or the tone mapping pass, wrote to the canvas, right? One of these two, depending on which,
Yeah.
whether we have this UI thing turned on. So now the scene has been rendered into the canvas nicely. And then we want to just add these additional debug images as an overlay on top of them. So we
Yeah.
don't want to clear the canvas, because if we clear the canvas, we're going to lose all.
Okay, I think that was confusing to me because these new passes aren't writing to the canvas anyway. They're writing to some buffers which are copying out.
No, this one is rendering to the canvas because render to screen is true here. Sorry, these textures have already been written. Like, these are just textures in the GPU. These exist as textures in the GPU. This render pass is rendering a scene with those textures on the quad. So like, okay, so here was if I don't have the debug pass on, here's the end, right? Like, I've written into the
okay. You're basically rendering 2 3D scenes.
Yes.
Okay. Well, actually one with okay, that's why it's orthographic, just to like simplify placing it on the screen. That's kind of wacky. So it's not like that image is floating in front of you and a little bit to the left in the 3D world. You're just rendered on top.
Right. Okay. And like, the reason we we could display this debug information in lots of ways, right? Like, the kind of most obvious way you might think of in a web browser or something is like, well, I just make an HTML image element. But like, in order to do that, I have to download that image off of the GPU again. Like, I have to like fetch those pixels off the GPU out of video memory, back onto like back onto the CPU side, generate an image object, put that into an image object, put that on the screen, only for like the web browser actually to upload it to the GPU again and generate a new texture and all that, right? Like, that's what would happen if I tried to put it into an image element. Because ultimately the browser is still, rendering on the GPU too. But by doing it this way, there's no like copying or anything. Like, that texture already exists on the GPU. I'm just saying, like, using the shader, bind to it and use it. So like, this is really cheap. And this doesn't strictly have to be another pass or anything. It just made it easy. Like, I could have also just called renderer.render instead of using a pass. But
so you had one last note in your org file about kind of tooling and or workflow and where we go from here.
Yep. So yeah, this is going to be landing, relatively soon. We're out next week, so it's not going to be that soon. But like you see, there's still some issues to resolve, like this camera stuff. Deciding what defaults are and all that. Also, you'll notice I'm rendering to like a fixed size canvas here rather than letting it dynamically resize. That's another thing to think about. It's like, well, now the cost of resizing is even higher than it already was not great that we resized. Like, whenever you open chat or something, we resize the canvas, which is like actually a pretty expensive operation, because it means it has to throw away all the existing frame buffers, create new ones. And then like when you close chat again, same thing has to happen. It has to, because they're different sizes, right? We actually like resize the canvas when you do that, instead of like, we don't overlay the chat bar on top of the thing. We resize it. So resizing the canvas is something we want to try to avoid, I think. And it's just going to become especially true because now when we resize that, we also have to resize the intermediate frame buffers, like the depth buffers we generate for this thing, the luminance, like all the stuff that we generate. Those things are all kind of no longer valid. And
aren't there like viewport calls or something like that where you can keep the canvas be large, but then
right. So we can do like, we would want to do that. Like, if we want to cover up like keep the canvas the same size, but when I open the chat bar, like only render to part of the canvas. That's exactly what GL viewport is for. It's like, okay, I want to like, when I'm doing in my vertex shader, when I'm deciding like, okay, where are these things, that coordinate space is going to apply within the viewport. It's like, where have I cut off this viewport? And so we can do that too. That's just not what we're doing right now. Like, by default, we render to the whole thing. I don't know exactly how you set up viewport in 3JS. I assume it has ways to do that. If not, you have to call directly through to the WebGL stuff. But like, the effects composer also needs to know about that, because then all of the passes need to only render to that viewport. And probably possible, but in just to simplify things, I've just like turned off all of the dynamic resizing stuff and just rendering to this area. But like that needs to be resolved before we can actually release this. And then I have right now I've just stuck it here into our big bag of stuff. I've at least regrouped them into graphics settings. The reason I haven't created a new tab yet is because, well, that's a whole another can of worms, because, well, we don't have enough room to display more than 3 tabs on mobile, and then we need to figure out how to scroll this, and I don't know. We'll get
Yeah,
there.
that's why
But
the
like,
top says misc and not miscellaneous, by the
yeah,
way.
yes,
Sorry.
because we don't have space for miscellaneous or
Oh, why are
we
you
got the
why are
preferences.
you showing all of our
Um,
failures?
but anyway, so now there's enable post processing, and you can separately enable Bloom. And I also just made this one of those ones where you have to refresh rather than trying to like have all the code paths where it's like, oh, you can turn this on and off. It's like, no, when you turn this on, we're going to initialize stuff differently. And so, um, um, so the, I think we'll ship this off by default. And so it'll be opt-in, like the user has to opt into like turning on this thing, just like while we're testing it and figuring it out. But then also like the artist will also opt in to like turning this on for their scene. And you'll do that by just in Blender, like I'm going to have this kind of catch-all checkbox. I don't know what to label it yet. I'm calling it HDR pipeline for now, where you'll check it, and then now you'll get these like additional, okay, you'll be able to set bloom and any other stuff we add here. I'm also going to use this probably as a opportunity to like introduce some of the breaking changes we've wanted to introduce with lighting. So if you've followed any of our the kind of previous streams Jim and I did about lighting, and there was lots of this stuff about your light map intensities have to be multiplied by pi, but like only if you're like not on mobile and all this stuff. We want to like make that simpler, but like it's a breaking change. And so I think I'm going to introduce that with this checkbox as well. It's like you're opting into this, like, okay, well, I'm like rethinking about my lighting and stuff anyway. And so we'll introduce those changes. I also think for a
Is that
bit,
environment settings component a component on GLTF, or
it's
okay?
a hubs component. Yeah. Like you add
Okay.
it to the scene. And we already had this environment settings component. Like the new thing here is just this checkbox.
Mhm.
Um, and right now I'm also having it replace this. I need to figure out how we want to expose tone mapping exactly, because this Blender Filmic thing uses a lookup texture, and I have to figure out how to integrate that into this tone mapping pass, or the tone mapping pass if we want to, or there's more to think about there. But so yeah, this checkbox is going to opt you into this new stuff, and I also think for at least a bit after we release this, we'll consider this like experimental. And what that means is I'm going to like not worry about breaking changes in terms of like, oh, we decide actually threshold should go from start at 2 or something, whatever, like arbitrary things we might decide, and like that means that all your scenes that are using this checkbox are going to like look wrong all of a sudden. I think
Are
that
games? I understand if editors are sort of give you toggleable things for tone mapping, but is it an unusual thing for a specific game to have multiple tone map? Like, oh, sometimes in the game we use filmic tone mapping, and other times we use Reinhardt.
Reinhardt. Yeah, I think that'd probably be kind of odd, but like in in Unreal, you can specify like what tone mapping to use.
That makes sense
I
to
don't
me
know.
because like tools for building graphical experiences, and the Blender add-on and hubs is definitely falls into that category. I'm just kind of curious if individual games tend to just pick one and then all the content works well with that
I,
tone mapping.
I would assume so, just for like visual consistency, if nothing else. Um, but yeah, I mean, hubs is pretty special, and I mean that is an option too, right? We can just say, and I don't think that would necessarily be a bad idea for us to do. Which is also why, like, right now when you check this, I get rid of the tone mapping box. That's one of the things I'm considering. It's like, well, should hubs just say like this is what the hub's tone mapping is, and I can configure things about it, maybe like I can change my exposure or whatever, but maybe Hubs just has a tone mapping, and well, that's what Hubs stuff looks like. And there's definitely an advantage to doing that, right? Like it would simplify the stuff I was talking about, where it's like, oh, we need to generate this reverse tone mapping, maybe if we want to do that. Well, if we know, okay, this is our tone mapping, we like the UI case, for example, we could do that like ahead of time. We can just say like,
Mhm.
oh, our UI colors, like when you generate a theme, um, well, we just modify all those values when we save them. It's like, okay, well, we're going to save these in a way that they're in like the linear space or whatever, that's going to get tone mapped to the color you asked for. Um, this is
We have a
especially
couple
like
of,
if
sorry,
you
go
want to
ahead.
do like the adaptive tone mapping stuff, like but might want to be able to configure it. But yeah, good question. Like I do think most games it's going to be like, okay, this is what your tone mapping looks like. You're going to tune the settings for different scenes and stuff, right? Like um if you don't have some sort of dynamic exposure, you're certainly going to like change the exposure settings. And exposure and tone mapping are like separate things, but they're kind of combined together sometimes. And in 3JS they are combined together. Um, exposure is just, you're taking the values and you're just multiplying them, or dividing them by some amount, like before you apply tone mapping. Um,
Hmm.
But
Mr.
yeah,
Franz asks, will these environment settings be added to Spoke as well?
um, we haven't added environment settings at all to Spoke yet. Like not even the current ones. I don't know what our plans are. I think adding the whole HDR workflow to Spoke is definitely a big lift. Like we don't have any of the environment map stuff in Spoke either. Generating environment maps in Spoke would be a whole other thing. Like Blender does all this stuff, and so I lean towards like no right now. But that's more of like a overall product decision, like kind of what we do with Spoke. In my mind, Spoke is like it's a kind of compositing tool. You use it to generate simpler stuff, and then once you're in the realm where you're really thinking about like, oh, what does my lighting look like, and and all this stuff, like you're going to need light baking, you need to think about your UVs, and like we could introduce all this stuff into Spoke, but like at some point we're just like recreating Blender, and Blender's already this great open source 3D editor with a huge community and add-ons and all sorts of stuff. um the fact that Spoke runs in the browser is really great, and the fact that I think Spoke is really easy to get started using, um I think is really nice for getting people who would not otherwise feel confident making 3D assets to start making 3D assets. I think it's like really good at that. Um, but in my mind, like and I've talked about this before, and this isn't like uh, I wouldn't read too much into this. Is like my personal take on it, not like the official Hubs team take on it. But like I think it's like we want to have a good path for graduating people from Spoke into Blender once they get to a certain point. I think, like I said, Spoke is really good for getting past that hurdle of like, well, I can't be someone who makes 3D stuff. That's like too complicated. Um, but I think once you get to a certain level, like it really benefits you to like learn learn a tool that is like that will you can grow into, and you can. It's not specific to Hubs. It's like it's just general purpose, like very useful thing. Um, that's my take on it. I don't know. There's nothing like I don't have any plans personally to to implement any of this stuff in Spoke right now, but that could change.
While we're speculating on the future of Spoke, I kind of, part of me wants to see a small explosion of tools like Spoke that are for different things. Like I think the various avatar editors that are out there are
Hmm.
kind of like Spoke in that it's a web UI.
Yep.
It renders 3D content with 3JS, and what it lets you do is configure something that outputs a GLTF file that's generally useful.
Hmm.
Um, it'd be nice if there were lots of those. Like, oh, I there's a museum that somebody made, like the one that you've been showing, and I want to swap out all of the images. So I have like a web-based editor for swapping out, like dropping in my list of images, and then like I have a little bit of a preview, but mostly it's like an editor that it's not for building the 3D
Right.
world. It's like just
It's for
composing some
configuring.
content.
Yeah, I mean, I don't know if this is Spoke or if this is another tool, but what I see um, being really useful is as a artist working in Blender, what I want my output to be is configurable scenes. I want to make the equivalent of like WordPress templates, and then I want people to be able to take those scenes and in something that probably looks kind of like Spoke, but probably like a good deal more simplified because I don't think you need all of the controls you have in Spoke, but I probably need a 3D view and I probably need to be able to like select stuff in the 3D view to some degree, or at least preview it. But then I want to be able to configure the scene like, oh, this wall actually has 3 different texture options I can choose from, or I can just like have a color slider to change some stuff. And then like there are a bunch of canvas media frames or something, and I can select like which images do I want to display in them. And like as the artist in Blender, what I did was I configured all the ways that this scene can be configured by someone. It's like, oh, they can select whether these chairs are here or not, or like there's a grill here instead. Like there's different options I can swap out, or there's different spots where you can put custom artwork, that sort of stuff. And then, like I said, that's like the WordPress theme. And then like what Spoke or some other tool becomes is like the WYSIWYG page editor. It's like you're not like editing the raw HTML and you're not editing the CSS and you're not going to change meshes and UV values and all that stuff. You're gonna move the knobs that the artist created and like the artist set up what can be configured and then you're going to configure it. And I think that that's to me where I see the future of. I don't want to say Spoke, something like I see a tool like that being kind of like a missing piece where it's like I see the one end of the workflow is like artists using Blender and our Blender add-on and the various other tools we build around that to like really create the raw configurable assets. Then that becomes available to people through whatever means, like they offer it directly. We have some sort of marketplace to offer it. I don't know how that happens, but then you take those editable assets, those WordPress templates, you configure them and you use them like that and that tool I think is missing, and that to me is like where the space Spoke is occupying right now is to me better served in that, and then the kind of actual creation of stuff moves more into the Blender workflow. um this is, like I said, this is all like roadmap stuff, and this is not my uh not for me to decide entirely, and I don't want to completely speculate on it, but that's like kind of my opinions on it.
All right, so we did our hour-long stream in
I was
135 minutes.
yeah, I was expecting this one to go over, but just looking at chat to see if there's any.
Yeah, I think people are right in identifying that tone mapping is something that you need to be able to override and shouldn't get in the way of a space that somebody's trying to make or something like that. Definitely worth arguing about the defaults and stuff like that. And also should be the same across clients, I think. Like, I think it's right to say that it's on a per object, per scene basis or whatever, not on a per client basis, because I don't know of any reason why you'd want two people to see the same object differently, unless it's clear that it's in different modes. Like, oh, okay, when you go to inspect, then tone mapping is always disabled because that's a different
Sure, I could
action
see
you're taking.
like, I mean, when we were talking about UI, for example, there are certainly like reasons you would say like no. One reason I could think of that you want to see something differently was like games often offer like a colorblind mode, for example, where
Hmm.
yeah, like you're changing the artistic intent of the author, but for accessibility reasons. But like usually the colorblind mode type stuff only applies to like functional elements. It's like, oh, like what team colors am I going to choose, and like what icon colors am I going to use, and that sort of stuff. Not like what does the floor look like. It's like it is true that the person who does not have normal color vision is perceiving the floor differently, but that was already the case. And so we don't modify the floor. I mean, you could try to modify the floor such that they're experiencing a more similar thing to someone with normal color vision is, but like I don't know. But
okay, accessibility reasons are a great reason to
yeah,
modify the color output on a per user basis.
but I do agree that like the asset is what should determine kind of the default tone mapping. Or
Not
at
necessarily
least
the asset,
parameters. Or at least the
just at
parameters.
runtime the object.
Yeah. But yeah, I think there could be benefits to us like standardizing on a tone mapping, like just saying, okay, like Hubs is going to use Filmic or something, and like that's our workflow. And because then you still can customize around that, right? Like you can configure your stuff. Like it's not like a moving target too, because like if you're generating assets to use in Hubs too, like I'm making this chair or something, it's like that's going to look different depending on the tone mapping. And I don't love the idea that like I can't use this in another scene as easily because of the tone mapping. That's like generally less of a problem now that and by now I mean like more modern graphics, you're using PBR type stuff. Like you don't have to like fake stuff as much anymore in terms of like you configure the material in such a way that it's going to look correct in this. Like most of what you're seeing here is like the light map and the like environment map lighting this thing. It's like, okay, this thing probably has a pretty simple material. It's like a green texture and like, they configured how rough it is and whatnot. But like most of what is giving this thing its appearance is all the lighting and most of the baked lighting. So maybe that's not a real concern.
All right. Well, thanks to everybody who tuned in. I hope this was fun for me. I learned a lot. I like this format. We should do
Yeah,
it
I
again.
think this like I have said this before. I think this format where like just someone asks a bunch of questions is really really useful. Like I love watching streams like this myself because it's like it's such a good way to learn because you like I said you so often have the same questions that the person asking has. So yeah, I think we should do this. We should do this more. And I encourage other people on the Hubs team too to do it too. Like I think we have lots of experts in lots of different things, and explaining stuff is both really useful and also helps you understand. Like check your understanding more too, because it forces you to ask questions that maybe you haven't asked yourself yet. Um, and if this is all interesting and you like talking about this stuff and you have opinions about tone mapping and what we should do by defaults and all that sort of stuff, come by the meetup tomorrow. We will almost certainly be talking about it somewhat.
All right, now we play the game of is Matt there?
Yes.
Is Matt